So consider the vector field f is y e to the x y I plus x e to the x y plus cos z j plus 1 minus y sine of z k. So we want to, so that's depicted over here. We want to show that this is conservative and then find a potential function for it. So to show this is conservative, we'll apply the component test. So we need to take del by del y of y e to the xy is e to the xy, so using the product rule, plus x y e to the xy. And that needs to be equal to del by del x of x e to the xy plus cos z. Well, the del by del x of cos z is 0, and then this will be e to the xy plus now y. Okay, so these are equal. Now, next we need to do del by del z, y e to the xy. That's 0. And that's the same as del by del x of 1 minus y sine z. And then finally del by del z of x e to the xy plus cos z is negative sine z, and that's del by del y of 1 minus y sine z. So this passes the component test, and then since R3, let's erase this, so since R3 is simply connected, this shows that this is sufficient to show that f is conservative. All right, so now we want to go about finding, how do we go about finding a potential function now that we know that one exists? So we're trying to solve the equations del f by del x equals y e to the xy, del f by del y equals x e to the xy plus cos z, and del f by del z equals 1 minus y sine of z. So we'll integrate del f by del x, just treating y and z as constants. So f is integral y e to the xy dx, and so that's e to the xy. Now normally we would put e to the xy plus c, but c is only a constant with respect in terms of x. So this c becomes a function g, which now only depends on, so this is constant with respect to x, but it can still depend on y and z. So now if we want to compare to del f by del y, so del by del y of this is x e to the xy plus del g by del y. And so comparing with this, we see that we have del g by del y has to be cos z. So maybe let me write out the function we've got so far. So f is x, f is e to the xy plus g. So now we'll do the same thing. We'll integrate g with respect we'll integrate g with respect to y. So g is integral cos z dy is y cos z, and now again plus something that's constant in terms of y, so now only depending on z. So now our f is e to the xy plus y cos z plus h of z. And if we take del by del z of this, we get del by del f. So basically, so far we've constructed a function f which has the correct del by del x and the correct del by del y. So final step is so del by del z of this is negative y sine z plus del h by del z. So we get that del h by del z is equal to 1, and so h is equal to z. So our potential function is, the most general potential function is f equals e to the xy plus y cos z plus z, and then now plus a constant c. So here is a graph of the level surfaces of that potential function. And again, you can adjust the sliders and see how that evolves according to the gradient field big F.